All right, without further ado, let me jump in here. Okay, so now the next requirement of our little app is that we have a button that gets us to the green screen. So we're going to put that button onto the main activity, and at that point, and hook up a click listener to the button so that we know when the button is clicked, and we can do what needs to be done at that point. So now we get to see the activity. I'm going to switch back to the code and go over to the Package Explorer and open up the red flashlight activity. Turn on some line numbers here. Okay, so this is the boilerplate generated activity that we saw. So it's pretty thin, but it's important nonetheless. So the class is named the same as as we saw in the manifest, which is important, and it extends activity, which is a framework class that Google gives us. And you can see that we're overriding a system or a framework method here on create, and you can probably guess that this is code that's going to happen to be called when the activity is created. So we're going to be looking more into activity lifecycle in later episodes, so don't worry too much about what you don't understand yet, but suffice to say that there is a lifecycle to each activity, and on create will be called once and only once when the activity is first created. And if you navigate to another screen, the activity will still be around, so that when you navigate back to it, on create won't be called. So this is for doing initialization. This is the place that you do the setup that you only need to do once. And one of those things that you need to do only once is to set which view you're going to be using. So in this case, we're going to say, and you do that through this set content view call. And now is the first time that we see this R class come into being. So the R class is sort of analogous to, if I switch back to the main XML, this @string in the text attribute of that text view. That's kind of the same thing. We're looking up a resource by name globally instead of trying to instantiate it and construct it and set it up the hard way. Our Android already makes it ready to go, so all we need to say is reference the thing by name. And you can see that in R class, just by looking at it from this, we'll look at the R class itself, but you can see that it's constructed sort of or laid out the same way that the directory structure underneath the resources are laid out. So that's an important thing to keep in mind too. Those resources are going to be, you're going to think about them the same way every time you use them. So I'm saying that the view that I want for this activity here is the main view. So now let me go open up this R class. I can put my pointer on it and hit F3, which is a nice Eclipse shortcut. And you can see this is the generated R class. If I come up here, there's the standard boilerplate, don't touch this warning. And you can see that there is a unique integer identifier for each one of these resources, and that's every time you add a new resource or every time Android finds out about a new resource, this R class will be configured such that each one of those resources is uniquely named by what you know as the developer, the file name or the resource name, like the color red, the icon drawable, which was picked up because its name is icon.ping, and Android puts those all together for easy reference. Okay, so that's R, and this is telling what view we want to use by saying that we want the main layout, which is a reference off of that R class. And that is how it actually shows up. So that is the magic behind actually showing the view. Now we're going to come back to the view and we're going to add a component. Let's see, on the main view we want to add a button. So I would come down here under the text view because, again, this is a linear layout, so I want the button to be under the label red. So I'm going to put it under the label red inside of the XML. And I start typing button and I get a little completion there, which is nice. This can just be a single tag. And just like all Android components, I'm just going to copy and paste this guy in here. We need this boilerplate layout width, layout height. I'll leave it at wrap content. We'll see what that does. But there's two other things that I want to do when we're still setting up these these attributes. One is I need a way to get a handle to this particular button in my controller, and that's done by setting up an ID. And IDs look like this, another bit of weird syntax. At, of course, because it's going to be a resource, but then you say plus ID, and then give it the name of the ID that you want. We're going to call this the green button. Now, what that means is, hey, Android, this is the first time I'm defining this ID. Give me a new unique identifier number in that resources file. So the first time you define the ID, it doesn't have to be in the context of this button. I mean, I could define this ID somewhere else for the first time, like say I wanted to reference the ID before it was set up. But in any case, the first time that I reference this green button ID, I need to put this plus guy in there. But after that, if I reference it for layout purposes, which we'll see in later episodes, by the way, if I reference it for layout purposes, then I need to say just at ID, not plus. Okay, so are there any questions about that? I don't know if I explained that as best as I could, but the first time that you define an ID, you need to say at plus ID. Sort of like incrementing an auto increment type thing, or if you're kind of thinking from the database perspective, or a database metaphor. Okay, so now that we have an ID, green button, you'll see later on, that's how we're going to get a handle to that button to listen for click events. And the last thing I want to do is put a label on the button, and that is done through the text attribute, and we're going to use a string. So I say at string, and I'll say that I want the label to be green, the green string. Of course, when I save, I'll get an error, so I come over here to strings, copy and paste line 3, and name this string green, make the content of the tag green. Now main is happy, no more errors. If I go to the layout, I see that there's a green button. Okay, so now you can see that's a little green button in the middle of the screen. If there are no other UI restrictions telling you to do something different, you should usually make something that the user has to interact with as big as possible, because they don't have a mouse pointer, they've got a thumb or a finger, and you want to make it something that they can hit with their thumb or finger. And oftentimes I've made this mistake where I put a UI element on the page that I can easily click with my mouse pointer, which is a pixel big, and then I show it to somebody else for QA purposes or something. They're like, well, I can't hit that button. I keep trying to hit the button, and I hit this other thing. So keep that in mind, that when you're clicking around with your finger or with your mouse, that's not a finger, and the finger takes up a bigger space. So in general, you want to give these components that users are going to interact with as much space as possible. And the way I'm going to do that here is by changing this layout width from wrap content to fill parent. And now you can see when I switch back to the layout what that's going to do. Now the green takes up the full screen instead. So that's a little bit of a bigger target for the user to hit. Okay, so now we've got a button on there in the activity land. Back in Java land, let me get rid of this annoying extra line noise here. I want to get a handle to that button and add a click listener. So that means that I want to listen for the event of and run some code when the user taps the button green. And the way I do that is I need to get access to a button first of all. So as I type this, I can hit Control Space, and I'll get if there's any ambiguity in that class that I just typed in here, Eclipse will give me a choice, but since it saw that there's no ambiguity, it actually imported for me this Android.widget.button class, which is what we're talking about here. And notice that the button class corresponds directly to the button tag name, by the way. So I'm going to define a button here. I'll call it green button. And now to get a reference to that, I say equals, need to cast this, to a button. And what I do is call this little helper method that is available to you on activity, which is find view by ID. And the ID is, as we just saw, the green button tag that we put on that, or green button attribute that we put on that tag, and we reference that through the R class, r.id.greenButton, and that is the unique identifier as far as Android knows about that particular component. And now I've got a reference to the button, and I can do things through code with that component. So what I want to do is listen for when somebody clicks or taps it. So I do that by saying greenButton.set on click listener, and pretty soon you'll probably get this particular incantation in your fingers because you're going to be probably doing this a lot. But it's a little weird, so let me just type it through and then we'll look at what we actually typed in a second. I'm going to make that a new view, which needs to be imported. So I hit Control Space, view.onClickListener. So this is an interface which is defined on view. And once I hit that completion from that pop-down menu, I get the interface is automatically expanded out into code that I need to conform to the interface. And then to make it syntactically correct, I need a little semicolon there to finish this. So this is, if you are, hopefully everybody's familiar enough with Java to understand that what we're looking at here is an anonymous class. This is a class that we're creating and defining in code on the fly without resorting to putting it into a separate class file and everything. I'm actually defining this class and putting code into this onClick listener, so I can run code right inside of here, but it's in the context of this new sort of anonymous class. Anonymous because I'm not actually assigning it to a variable or anything, and I'm not actually making my own extended version which implements this interface. I'm able to make this class right here, so hopefully everybody understands that little sort bit of Java red tape. But onClick is where the thing is actually going to happen. So what I'm going to do now to prove that this click listener is going to be called is I'm going to use the debuggers to show you that the standard debugging practices will all work with Android. So what I'm going to do is double click in Eclipse on this line number 18, and since there's actually nothing there, it jumps me down to the line 19. But I'm putting a breakpoint here at line 18 or line 19 as it wanted to do, and we're going to run this again. So last time I ran the application by going here to the project and right-clicking and saying Run as Android application. After that, I can come up here to this cute little play button and say run this guy, the simple flashlight guy, as an application. But I can also go here to the debug menu and say debug simple flashlight. So that's what I'm going to do. Now that will run through the same process of uploading the application to our emulator. So now the emulator has our new code in it, and it's waiting for the debugger to attach. Starting the code, and the debugger should have attached. If I open up the debug perspective, I come up here to the top right, click this little kind of a tab layout deal, and open up the debug perspective. That shows that in my debugging pane here, I am connected to the Dalvik VM on localhost 8610, which is our emulator, and I can see there's a couple threads already running, and that means that I am connected to with a debugging session to the running code inside the emulator, which is great, which is exactly what I want. So now when I click this onClick listener, when I click this button, the onClick listener should stop us at that breakpoint, and it hops us back into Eclipse. And now here I am stopped at this breakpoint inside the onClick listener. And we can inspect our state at that point. You can see that this v variable that's passed in is expected to be a view. And we can see that it is actually a button, which subclass is view. So now I can see what's going on with my button. There's a whole bunch of interesting stuff, like for instance this boring layout metrics that seems to be on the compiled into the buttons class. It's interesting. I expected that to be more like a Boolean. Yes, this is obviously boring, but it's not. Anyhow, so now this is how you debug an Android application, just like you normally would in Eclipse, which is pretty useful. You can see the stack trace here and kind of go through. It looks like a whole bunch of things led up to this click. all sort of dispatching this touch event down to the point where the button was actually clicked. What's interesting to see here is this linear layout got a click event, and it said I'm not doing anything with it. So it's passed down through a bunch of other layouts to the point where it finally gets to our button class, perform click, and that is all happening within this view thread, which is only one of the threads that are running on here. So that's kind of a look into how debugging would work, just like normal. So I'm going to let that pass through with the resume, and we are done with this particular step. So what we've done is add a green button to the layout, labeled green, and we've added a click listener to that button. So are there any questions with what we've done so far?
Can XML files be changed dynamically while the application is running?
I think what you're actually asking is, can you change the view hierarchy dynamically? And yes, you can. You wouldn't do it through changing the XML files because those are all compiled into. Those are what they're made into, especially the layout files is what I think you're talking about. They're made into a more like a binary version of themselves so that they can be kind of hydrated, or what's called inflated, what Android calls them inflated at runtime. So you're not actually dealing with XML, because XML is bulky and verbose, and it's nice to read, but it's not nice to work with. So there's actually a phase during compilation where those XML files are no longer used. But you can definitely mess with the view hierarchy and things out there on the view at runtime.
Let's do just a couple more questions, and then we'll move on so we can do the button. So we have a question in the audience, and then we have a couple more in the chat room. So do you want to grab the mic?
Can you grab the mic? Thank you.
Is it too early to talk about how we might internationalize those strings?
I was going to be going through that in a later version, but let me just give you a quick preview. So if I hop back here to Eclipse, can everybody see Eclipse again?
Yes.
And I'm going to disconnect from the debugging session. I guess I didn't need to, but I'm going to switch back to the Java perspective, go into the Package Explorer. So what I would do is inside this values directory, I would have a strings, and I'm blanking on what the syntax would be, or the convention would be, but basically I'd be naming this file strings, I think, _en_en, big En and little en, you know what I'm talking about there, for the English internationalization and English localization. And I could have as many strings files as I wanted, and using that file naming convention. So that's where the naming convention does matter, but only as far as those localization codes are put into the name of the file. And that way, and in fact, beyond that, it's not just for localization and internationalization. You can also have different layouts for different resolutions and different orientations. So I can use a naming convention there as well. So I could have main, I think, I can't remember if I do something like portrait or whatever, but I could have a screen resolution dependent layout file. In Android, there's a way to get Android to automatically use those. So as far as the localization goes, I would have a strings file for Spanish and a strings file for French, and so on and so forth, with the same keys and values. And then Android would automatically, I guess based on the preferences of the user on the device that it was on, load the right strings. And you have some programmatic control over that as well.
Does it create a single binary then for all resources for all languages?
I'm not sure how it's going to deal with the actual content, but those will all be referenced through the R file. But you, as a programmer, just have to worry about saying I want the string with this key, and it will take care of the rest of the details. Does that answer your question?
Well, it's really more questions of the size of the binary. If you have to put localized art assets in, if you end up with one binary with all languages and you're supporting 50 languages,
well, I mean, think about the time that it needs to be supported. So you could. I guess you're saying like, can I upload the French version to the French marketplace or something like that?
That's right.
Right. Okay. Yeah. I guess I'm not sure of that workflow. I will look into that, and I'm not actually sure when I'm going over. I was thinking of going over that in a later class, not even this set of 5. But I will try to look into that. Oh yeah, maybe this is a good time to ask Elizabeth. There's going to be a forum for this class, right?
There is, yes.
Okay,
that would be a great question to ask in the forum and answer in the forum.
Okay, so let's take this to the forum.
We don't have one set up yet.
We will get that.
So I have a question about the emulators.
Yeah.
A lot of people are noticing that emulators are slow, especially phone emulators. Is there any way to optimize this or ramp up the speed? Are there any settings that we can use?
Not that I know of. I mean, the slowest part for me is the uploading process, like the build process. I have enough time to forget what the heck I just did every time I upload to the emulator and look at the new code that I just deployed. And no, I don't really have any. I sometimes notice that the device is faster, so sometimes I'll switch over to the device if it's really annoying me.